Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on building energy systems and auditing. In the module number 5, where we are now discussing on the energy conservation and thermal comfort. This is the first lecture on the thermal comfort, and this is the lecture number 24. So, we will see in this lecture there are the concept of the body heat, the human body heat and the heat balance, the thermal comfort parameters mainly, and we also see one of the very important concept of MRT or the mean radiant temperature. So, in the introduction that the thermal comfort, we always say the thermal comfort in our day to day life, in our also in the scientific communities also say about the thermal comfort. How the thermal comfort is defined, that is very important. So, it says that it is the condition of the mind which actually express the satisfaction to a particular thermal environment. It is the mind, and also in the ASHRAE 55 2004 also stated the similar way as the ISO 7730 has stated. It is the condition of the mind that express the satisfaction with the thermal environment, and it is assessed by the subjective evaluation. This is very important, it is a subjective evaluation. So, a particular thermal environment which I may feel comfortable, you may not feel, it is depend upon lot of parameters, lot of other type of the ethnicity, the dresses, the environment, the way we have bring up from the since our childhood and all. So, there are lot of the subjective parameters are there. So, they stated that both the courts are stated that as it is a mind, so it has to be some kind of the satisfaction with the mind. So, definitely the parameters has to be evaluated by some kind of the subjective evaluation. So, let us see today in this particular lecture number 24, what are the various parameters. In the lecture number 25, we will see the indices, what are the thermal comfort indices. So, this is the very well defined and well defined equation that actually state the heat balance equation of a human body. So, it is stated that in the left hand side there are so many parameters. It starts with a positive parameter of m. So, there are some kind of gains. When there is a positive, there is a gains. If there is a negative part, there is a losses. So, what are the gains? There is a m. M is always going to be a gain. So, m cannot be negative, which is a metabolism. So, it is the human body metabolism that will produce some kind of a heat. Sometimes it is produced a high amount of heat, sometimes it may not. So, if we are very active in our the actions and all, suppose we are running, we are playing some games or so, or maybe we are working with some kind of a gymnasium, the exercise or something like that, the metabolism will be high. But if we are in a leisure, we are sleeping, we are sitting down in a balcony, so definitely the metabolism will be much less. But this cannot be negative. Next three parameters CD, CV and RD are nothing but the conduction, convection and the radiation. They are sometimes positive, sometimes negative. So, conduction is the contact temperature difference, or the due to the temperature difference, contact temperature difference, the contact temperature difference between of my body and this back of my chair, there may be a temperature difference. So, there is a conduction of the heat will be flow from one part to the other. So, there may be a chance of negative. So, there may be a conduction losses if I have the backrest, if it is cool enough and the temperature is less than the body temperature, I will going to lose some kind of a heat. Second one is the convection. Convection is the if there is air which is warmer than body, or if there is air which is the less than the skin temperature or cooler than the skin temperature or so, there is a convection will take place between these two. So, there may be a plus or minus CV also. Then the radiation. So, radiation from the sun, maybe if you say about it is outdoor thermal comfort, say directly it is under the sun or maybe under the sky or any kind of the radiating body, if you are very close to the window which actually radiates lot of heat. If you are very close to the ceiling which is exposed to outside and that is very hot, or even in the night it is very cold. So, there is a situation where the human body may lose heat or it may gain some kind of heat. That is why the CD or the CD the radiation part is also plus or minus, that is because of the sky temperature or the window temperature. Suppose it is a snowfall outside and if I am going to lose some kind of heat. Suppose it is it's a hot the month of May, June, the hot scorching heat outside, then I am going to gain some kind of a heat. So, that is why it is plus or minus in that particular equation. But lastly it is EV, which is always loss, which is the evaporation. So, because of the moisture and the sweat in our body, we will always going to evaporate. Always going to evaporate means it is actually the body mechanism which actually creates some kind of a sweat, and as and when sweat is created, it will going to evaporate, and as and when it is evaporated. So, I am going to lose some kind of a heat, and that heat is a latent heat. So, it is always going to be negative. Then because of the sweat I am not going to gain anything. So, it is always going to lose some kind of. So, all these things if you add and if you subtract and all, so there may be lot of permutation combinations possible and lot of scenarios can be possible. So, that is equal to the right hand side, which is delta S, some kind of the balance heat of the human bodies or so. Now, see this delta S will going to fix up your body condition or the mind sometimes, and from that point of view we can say yes, we are in comfortable, thermally comfortable, or no, we may not, or maybe we can say it is neutral, we are not so comfortable or it is not so kind of bothering me. So, let us see how that particular things will take care in the next slide. So, delta is the change of heat storage, so that we understand. So, our body temperature is almost about 36, 37 degrees centigrade, around 37 degrees centigrade. So, there are some losses always going to be happening, there are some gains in other side. So, based on that, if it is thermally balanced, if I say then it is this delta S equal to 0, and I can keep my body temperature exactly at 37 degrees centigrade, and probably I will feel very neutral. I will feel very neutral, that I am not comfortable. Of course, that neutral is also a type of comfortable, that I am not going to feel any the cold, or I am not going to feel any kind of a hot atmosphere or so. This environmental parameter, how that is going to relate with this 4 things in my equation. Metabolism is not at all directly related to any kind of the this environmental parameter, is the body parameter, the body biological parameter mostly, and the evaporation is actually directly or indirectly linked with the dBT, air velocity, and the RH. So, if these are changing, the evaporation rate and everything will going to change. Radiation between the two bodies is going to be a thermal conductivity and all those, so that there is a temperature difference, and this temperature difference is, yes, sometimes it is environmental parameter. Just now I told you, if this is a snowfall outside and there is a glazing, there is a window and you are very close to the window, there is a kind of a change of radiations or so. The convections, yes, there is a air velocity, maybe there you are under a room which is does not have any kind of air conditioner, it has a natural the air flow. So, based on the what temperature of the outside dBT, that will play a role. There are some human psychological parameter also. Yes, metabolism is, of course, it is the human psychological, sorry, not psychological, I am sorry, it is the human physical parameter. So, it is depend upon the surface area of any human being, the weight of a person, it depends upon the sex, it is depend upon the age of a person also. The evaporation is also, yes, it is a sometimes it is a physical parameter, its ability to produce some kind of a sweat. Your surface area is uncovered with the clothing, the surface area is covered with the clothing. Those similarly, the clothing and your surface areas are also come into the picture in time of your the convections and the radiation. So, now if you see there is a balanced kind of a scenario in this particular graph. In the x axis is the temperature high or low based on our body temperature, and in the top I have written down this particular the human body equation, the heat storage equation. And on the x axis right hand side it is the clothing, and the left hand side it is the metabolic rate. So, now the body temperature will feel 37 degrees centigrade, it is normal body temperature when this delta S is equal to 0. So, your loss and your gains are almost equal and there is no delta S. But if there is a hot condition, that means the room is hot. So, there is a much more positives, there is a less amount of negatives. So, this delta S has positive value. Now, it is how much positive, it may be a small positive value, so you can accommodate that one. If it is little bit more, you can still accommodate, and if it is finally very high and if it is more than, your body temperature will going to change, right, because delta S is positive means your body temperature will now increase from 37 to 37.5, 38 like that. And if the body temperature is more than or almost equal to 41 degree, that means almost 4 degree above than the 37.7 degree, which is like a very high fever kind of a thing. And if this is so, you are in a trouble, you will be really in trouble, you may go to a kind of a shock or maybe a kind of a trauma, or that may be sometimes known as the heat stroke, that kind of scenario. And in the medicine or in our clinical community, they call that is a hyperthermia. So, in that time what we do actually, if you see, we want to increase the heat loss, we want to try to be more negative. So, we sweat because it will be evaporative cooling, then the EV will be more. We want to remove our clothes because that will going to increase our body surfaces with the atmosphere, and so, or we can go for a very light amount of clothing. So, we turn the fan, that will be our habit because we want to increase the airflow, that will going to evaporate the sweat from my body. So, that will going to again some kind of a loss. We increase the body surface and we want to spread out, we can lie in the bed or somewhere there. So, we want to, as much as we want to increase the body surface area, that will actually decrease those heat loss by evaporation or by the convections and all. So, decreased, or also we try to decrease the heat production. Heat production will be come from the M, the metabolic rate. So, we want to decrease that one. So, we will stop eating. If you eat, then it will start giving you lot of the heat generations also. We will stop eating, we will decrease the any activities, we will not go for any kind of the exercise or something like that. So, you see it is a body, we have light clothing, and we will have to have the low metabolic rate, we can sleep, we can lay down, something like that we will do. In other word, if you just go back to the other type of scenario, when the cold condition, the condition is very cold and your S, the delta S is negative. So, and if this delta S is negative, will decrease your body temperature from 37 to lower, and if it is less than 35 degree, you are again in trouble. So, it will go to a hypothermia, it is called hypothermia, and it again go back to some kind of, or you may have some kind of a attack. So, cold attack or something like that. In this scenario, we have to decrease the heat loss, we do not want to lose my heat. So, what we will have no sweating, our body will not going to sweat, number one. Number two, we will apply heavy clothing, that we do not want to lose any heat from my body. So, we will have the winter clothing, we have to sheltering from the wind, we do not want any kind of the fan movement or so, we will shelter from the wind, and we will reduce down the body area by folding arm and legs. So, we will be just like we will not going to spread, we will going to go for a reduce our body surface area. And in the other side we will what we will do, we will try to increase the heat production. So, we have to increase the the metabolic rate. So, there are 2-3 ways. We will shiver, we will just like shivering will do some more work, and that will produce some kind of heat. We may eat something, maybe the hot milk we can eat, that will increase my metabolic rate, or we will do some activity, shivering or some activity, we may run, maybe something like that, or do some kind of activity, or maybe we can do like some kind of the activities like that which can produce some kind of a heat. So, that way these two things will be balanced with each other. So, from this perspective we can see the thermal comfort parameters are depend upon so many environmental parameters, mainly these 4 environmental parameters. The air temperature, we all know dBT, the mean radiant temperature MRT we will discuss now, air speed and the humidity, whereas there are some personal factors also. The first 2 personal factors are very important, the activity which is the metabolic rate, and the clothing. Clothing, you know, your the amount of clothing and all these things also has to play a role in your the condition of your this heat balance condition, and also that lead to the thermal comfort also. Other than that, these 2 activities and clothing you can map, but other than that, the state of your health, the adaptive or the optimization, then the body type, you are thin or you are a fat, your age, gender, genetic or ethnic group, you are coming from which kind of the climatic areas, are you from childhood, you are growing in which climatic area, those parameters are also going to affect, but those parameters cannot be mathematically modeled. Your mood or your attitude, your intensive drive or enthusiasm, body rhythm cycle, your diet, your social situations, whether you are relaxed, whether you are in a fear, whether you are in a panic. So, you are in a stress mental condition, those are also come into the play. Also, you have to have your the standard of living, that also come into the play sometimes if you are rich or whatever. So, those parameters from 3 to 13 cannot be mapped properly, because that is why it has been told that it is a subjective parameter. The thermal comfort is a subjective parameter. So, but let us try to do some kind of indices. So, from that point of view, we have those 6 parameters, 4 thermal parameter and 2 the human parameter. So, first human parameter is the metabolic activities. So, metabolic activities are unit is MET, and that 1 MET is almost equal to the 58.2 watt per meter square. Okay. So, if this is the chart of the MET which comes from this table is the ASHRAE 55 table. So, different activities has some kind of the different MET values. Suppose it is sleeping, you are 0.7, whether you are standing and relaxing kind of a thing, it is 1.2. Suppose you are having some kind of a shovel work, it is almost 4.8. So, heavy work is more. Suppose somebody is sleeping in this particular figure 0.8 MET, somebody is playing the badminton or maybe a table tennis, it is 4 MET. So, based on that, so the clothing insulation now depending upon our clothing, depending upon our different type of clothing or so, it has changes its value. So, if you have a light clothing, just nothing, only Bermuda or something like that kind of a thin scenario, it is 0.15, and if it is a very heavy clothing, in the winter clothing, it may go up to 1.3, 1.4 also sometimes. So, based on that, it has been changed. Next is the mean radiant temperature also. Mean radiant temperature is a conceptually it may say that actually inside a room, inside an interior room, all the surfaces and also all the equipments and all the furnitures will going to radiate in some form the heat, and based on that imaginary room has been conceptualized which can be treated as the same with the actual room if there is a same amount of radiation heat exchange from the surfaces. So, based on this particular phenomena, we can say this particular a surface from the various object in the surface. There may be wall, there may be ceiling, there may be some light, there may be some kind of a room heater. So, each and surfaces, even there may be some kind of table, chair, which are sometimes having some kind of a heat generating source. So, from that sources the heat flux or the radiate towards the center or maybe the other side, or you may say that a particular heat flux is going to the flow from lower temperature to the higher temperature, sorry, from the higher temperature to the lower temperature zone. So, imaginary way we can think in the center or maybe any point in my particular room. Suppose in this classroom I am sitting in one of the corner. So, if I want to feel that what will be the mean radiant temperature. So, at this particular point I need to see that how much exposed area, 3-dimensional exposed area I have from the different part of the radiating bodies, and those radiating bodies are maybe wall, ceiling, or maybe some kind of equipment or maybe some kind of a furniture. So, based on this particular concept, a Blading's formula can be used to find out. There are various formulas to find out, but this is one of the easy way to find out the radiant temperature, mean radiant temperature, where it has been stated that it is the G, Tg is the globe thermometer temperature. So, globe thermometer is actually used to find out the mean radiant temperature, but not directly. You have to use the globe thermometer temperature and use this equation where Tg is the globe thermometer temperature, Va is the air velocity, and Ta is the dry bulb temperature of the particular thing. So, why globe thermometer? Globe thermometer is a normal thermometer kept within the black color globe. So, it actually appears to be, or it has to be assumed to be a black body, and it will going to collect all the heat from the 3-dimensional surfaces. So, definitely it has a little bit higher temperature with respect to the ambient air temperature, which we called actually as a dBT. So, based on this you see there is a difference Tg minus Ta, always it will be the globe thermometer temperature will be little bit higher, little bit, maybe 0.01 degree to 0.5 degree. Sometimes if it is in the floor, the topmost floor, and your ceiling is exposed to the outside temperature, hot temperature or so, then maybe it is 2 to 3 degree changes also can be noticed. So, this within bracket terms is going to be positive always, and it is under root V the velocity of, so it will be little bit less. So, by virtue of that, this Tr, that is the mean radiant temperature, will be slightly above to the globe temperature also. If there is no air velocity, theoretically we can say it is equal to the globe temperature, otherwise it will be little bit more globe temperature also from the globe temperature. So, how we can find out? One way to find out this mean radiant temperature is directly with the globe thermometer, but if we know the partition wall and the exterior wall and the ceiling temperature, then theoretically in 2-dimensional way, or you may say it is kind of approximately we can calculate. So, I have shown a figure in it is a cross section of a room, and my point of interest is this. This is my point of interest, and from the point of interest I have subdivided the aerially subdivided in the 2-dimensional plane all the objects, those are having different type of temperature. I am assuming that floor is of 28, not assuming, maybe the floor is of 28 degrees, ceiling is 48 degree, partition wall is 26, like that, window is 52 degree, very hot, and based on my position, the angle which comes from 2-dimensionally comes from the window is 20 degree, and the wall ceiling is suppose 90 degrees, floor is also 90 degree, and the partition wall is 120. So, sum of all those angle must be equal to the 360 degree. So, it is approximate. Why I have not taken into account the 3-dimensional angle, number one, that should be, and also I have not taken the other two side of the wall, because that gives me a 3-dimensional in character. So, the temperature are listed down and the angles are also listed down. So, what you have to do, the temperature and the angle has to multiply. So, these multiplications of each surfaces are there, and with respect to its angle is multiplied and it has been summed up. And the summation is 12,600 is the total, and that is divided by the whole angle, that is 360 degree. So, that means it gives me around 35 degree the mean radiant temperature. Again, this particular way of calculation is, I must say, it is a secondary way of calculation, just to give you a kind of a broad idea of the mean radiant temperature. This has been devised, but this has been without, if you do not have that sensitive instruments like globe temperature or so, you may devise it like this, but it will be little bit approximate in the calculation from the point of view. It is better to go with a globe thermometer, and from the globe thermometer, even the globe thermometer temperature in a very static kind of a wind condition, even that particular globe thermometer can be read as a MRT in absence of other parameters or so. So, this particular the angle multiplied by the aperture angle multiplied by the object temperature, summing up and divided by the whole angle, that is 360, can give you a MRT values or so. So, there are sometimes there is a radiant asymmetry. The radiant asymmetry means, suppose you are situated in a certain position in a room, and the two part of the room, maybe the top and bottom, or maybe the left side and the right side, are having two different extreme temperature difference. Maybe there is a window which is actually radiating heat, and it is 52 degree or something like that, whereas the other side is a partition wall or some other window which is exposed to the another room, which room may be of your air conditioned room, and that window may be of around 18 degrees or so. So, how close you are towards 18 degree the window, or how close maybe you are to that 50 degree window, based on that there is a radiant asymmetry. You know, your back side or may feel like it is so cold, and maybe the front side may not be that much, because your comes under the thrust of the heat, the radiant heat. So, that is a kind of a asymmetry. Asymmetry is calculated, and the comfort, the dissatisfied percentage of the dissatisfied is, again it is a subjective criteria, is placed in the y axis, and this is the radiant temperature asymmetry is placed in the x axis. The lower part is the Celsius and the upper part is the Fahrenheit. So, there may be a warm ceiling, there may be a cool wall, there may be a cool ceiling, or there may be a warm wall. So, there are various scenarios. So, this radiant asymmetry can be also calculated like this. So, I have calculated a radiant asymmetry. So, the ceiling the temperature is 60, whereas the floor temperature is 20, very asymmetrical scenario. The wall temperature are 30. So, I have distributed the angles with 60 degrees in the wall and the 120 degrees for the ceiling, and I have calculated the MRT above that point, the black color point, the black dot, how much. So, as the black color dot, my point of interest, the above temperature MRT will be high, because it is exposed area, exposed 120 degree with ceiling of 60 degree temperature. So, that gives you almost 50 degree temperature in the MRT above, whereas the MRT below will be less, because it is 120 degree is exposed to the floor, which is lower temperature, only 20 degree temperature. This 20 degree temperature, this actually create a issue. Other all the parameters are same, the wall and all are the same, 180. So, this is going to be 23. So, there is asymmetry lies 50 and 23.3. So, there is a 26-27 degree asymmetry lies between the above and below. So, let us see what happened if it is 26 degrees. So, I drop a line from 26 degree, and if it is a warm ceiling, So, I may say that it is very much because of the very much discomfort, because this may lead to somewhere where maybe 80 more than 80% people will be discomfort. So, something like that is the radiant asymmetry. So, this radiant asymmetry is also going to bother a person. I mean, if the radiant, suppose if I say because of the, if 10 degree is the radiant asymmetry, so and if it is due to the warm ceiling, just like my, I can say that this is the around this is 10, 20 to 18 percentage the people will be dissatisfied with that. Okay. In my case it is 26 degrees, so much more people will be dissatisfied, almost about 95% of the people will be dissatisfied with that. So, that is the radiant asymmetry. So, what we discussed today is that the thermal comfort of a human body, we understand the body temperature balance equation. We also understand that it is a depend upon some environmental parameter like air temperature, relative humidity, air speed and the mean radiant temperature. We have thoroughly discussed about the parameter like the mean radiant temperature. There are two more responsible parameters are also there, which is a metabolic rate and the clothing insulations. So, in the next lecture we will go to the thermal comfort indices. Thank you very much.